So, welcome back, everybody. I hope you enjoyed lunch or breakfast, wherever you are. Maybe it was your evening meal, and I hope you managed to join the Lunch and Learn session as well. So, up now, it gives me great pleasure to welcome back Mark Nelson from, well, I was going to say the IBM RACF development team, but he's fresh back from Hawaii, aren't you? And so straight into the thick of it, we're coming to present to us. So this is session 1 AD. Don't forget your feedback, and any previous sessions you didn't manage to record feedback for, please do take a moment to do that. But yes, of course, we had a new release of ZOS, and that's a new release of RACF. So without further ado, Mark, take us through it.
Welcome Excellent. Back. Great to be back. Good afternoon, everybody. Good morning, depending on your time zone. Thank you, Henry. How you doing? Great to see everybody. Really wish we were together in person. That will happen again sometime, hopefully really, really soon. But until then, we will press on with these electronic delivery mechanisms. One of the things we can't do is when you ask questions, I can't give you chocolate. I could say that if you ask a question, I'll eat a chocolate for you in your honor, of course, but I really shouldn't be doing that. But yes, please do ask questions. I'm going to ask that we put them in the chat, though, and then Jamie will interrupt me as appropriate and tell me that there are questions and read them to me. We have a lot of material to get through, so let's get to it. Yes, this is the update for RACF for ZOS V2R5. The things we'll be covering are, we've got some new health checks. We've enhanced our pass ticket support. We've got some header files for those of you who like to write things in C. We're giving you the ability to restrict what alter authority can do, alter authority on a discrete profile can do. Certificate fingerprint support, a way of showing you a indication or a label, if you will, for certificates that's unique to every certificate. We've got some FIP support in Kerberos, and last we had a statement of direction about the encryption of the RACF database and moving it to a VSAM base to take advantage of pervasive encryption for data sets. We'll talk about that and how you can move to that. It's not there right now, but in V2R5, we do have the ability to use a VSAM data set, and well, let's get to it. So let's first talk about the RACF health check support, some new stuff we've been doing. We've been doing health checks for ZOS since the health checker, IBM health checker for ZOS first came out. Came out in ZOS 1.7 and rolled all the way back to ZOS 1.4. And RACF was one of the first components to put checks out there. We put two out there, the famous RACF sensitive resources check and the RACF GRS RNL check. Those are our first two, and ever since then we've been adding more and more. Pretty much every ZOS release has some new RACF checks. We put some in the service stream. We have well over 20, and we're introducing a few more. Now, just the whole purpose of the health checker for ZOS is to let you know when you have a system misconfiguration that you should attend to, because that misconfiguration is leaving your system exposed one way or another. Might be an availability issue. But the concept is the health checker doesn't change anything. It simply advises you when there is something that you need to take a look at. It's not everything from a security perspective. Even that RACF sensitive resources with all the things it's looking at, it's not everything. You still should be looking in using other things, Z-Secure, other products that help you do a more thorough review. But these checks are really just a baseline set of controls. So the new 5 that we are introducing in ZOS V2R5, a check that will harass you if you have not put yourself in protect all fail mode. Protect all fail mode is the mode that says if there is no RACF profile for a data set, then access should not be allowed. So protect all fail. It's been a recommendation for years and years and years. This health check will raise an exception if you do not have protect all fail enabled. The second of these new health checks is a health check that will validate that you have seterops erase all enabled, right? So the concept of seterops erase all is that any data set, when it's deleted or space is released on it, the space will be overwritten. I hope everybody realizes if you do not specify erasure for a data set, then when you delete the data set, ZOS merely deletes pointers to where the data is. The data still is out there on that virtual spinning DASD somewhere. So seterops erase all is what the RACF erase on scratch check is validating. The next one is the RACF PTKT data class. This is actually very much related to the pass ticket support, not the new support, but pass tickets. The concept of the pass ticket is a password substitute, cryptographically generated. The algorithm is public. The only thing that's really secret is the keys that are used. So it's a cryptographic algorithm to generate these password substitutes. If it's a cryptographic algorithm, it has to be a key. You have a choice of where you put the key. You can put the key in the RACF data set, in which case the RACF key, that key will be masked, or you can put it in ICSF. Now, in general, if anyone gives you a choice of storing cryptographic material in place A or in ICSF, the right answer is to put it in ICSF. So the ability to put things in the RACF database, these pass ticket keys, is supported, not recommended, and this health check will look at your PTKT data class, which is where this key information is stored. If it sees any keys stored in RACF, it will raise an exception. The next of these new checks, number 4 on the list, RACF Sysplex Communications. Most people are using their RACF database in a shared environment. We strongly recommend that if you have a shared RACF database, even if you are not in RACF data sharing mode, right, that you enable RACF Sysplex Communications. RACF Sysplex Communications is a way where RACF, in that shared RACF environment, each RACF is communicating with the other RACF systems, and you get a couple of benefits from it. One of them is when RACF has to delete something from a cache, a specific type of cache, a VLF cache, we can purge out individual elements without having to purge the entire VLF cache. So that's one advantage. There are a couple of other advantages. Enabling Sysplex Communications is not, it's a systems programmers thing. It's recommended. It's not that bad to do, and hence why the check is going to be looking to see if you're in Sysplex Communications. The other advantage you get with Sysplex Communications is you get a consistency across all of the data set names tables and range tables. Right, so the way it works is the first system, which IPLs, sets what the range table and data set names table are for all of the ones in the Plex. So it's a good thing to enable RACF Sysplex Communications. The last check validates that you've started the RACF address space. Now, the RACF address space, you don't need the RACF address space to do request equals verifies, which are logons, or request equals auths or fast auths, which are authorization checks. There are some RACF functions that do require, so IRXUtil and a few other things require the address space, but what it's really useful for is you can log on to a ZOS console and then issue RACF commands from that ZOS console. You issue the commands from the ZOS console, they execute in the RACF address space, but you had to have started it. So that's the reason why we recommend that you start the RACF address space. It's a good recovery thing to have. So those are the 5 checks. These checks are medium severity checks. They run every 24 hours. And if your environment doesn't support something, erase on scratch is probably the one that would be the most, I wouldn't say problematic, but you might have an issue with. I work with a number of clients who've set her up, erased all, turned it on, and they haven't seen an issue. But I did have one client that had they had a batch reconciliation master file job that ran for 12 minutes. When they turned erase all on, that job ran much longer, upwards of about an hour, and they couldn't support that. So they had to not go erase all. Well, if the health check is telling you and raising an exception, you can disable the check. It's a PARM live setting. We do just ask, that when you set the PARM live setting, you probably want to put something in that PARM live setting that indicates exactly why you disabled that specific check. So new RACF health checks, always fun to talk about. Next topic, enhanced pass tickets. So I mentioned when I was talking about the health check, this concept of the RACF pass ticket, a password substitute, cryptographically generated. And the support was originally designed for single sign-on applications. I think we've all seen these kinds of applications. You log on to the application with your ZOS credentials, your user ID and password. And then when you want to log on to TSO or KIX or IMS, whatever it might be, you simply check a box or select something, and a logon occurs under the covers for you to that application environment. And the way they do that is you log on to the application, to the single sign-on application. And once you've done that, and you decide you want to move to one of the application environments, TSO, IMS, CICS, whatever it might be, You click on that, and then what happens under the covers is the single sign-on application generates this pass ticket and then puts that pass ticket and your user ID into the logon request. And then the application environment gets your user ID and this pass ticket, passes it on to RACF, and RACF can evaluate it, make sure that in fact is a valid pass ticket for that particular environment. So that's the concept of what a pass ticket is. Lots of information about these in the RACF Security Administrator's Guide, now in RACF Macros and Interfaces. As I mentioned earlier, the algorithm is public. It's in the RACF Macros and Interfaces Guide. The only thing that's key in this, that's secret in this, is the key, the shared secret between the generator and the evaluator. And if the generator and evaluator are the same ZOS system, that's great. I mean, you've got the key stored somewhere, could be in a RACF database, as I said earlier. The better choice would be ICSF. Right, so that's the concept of the pass ticket. And they really are password substitutes. So any interface which accepts a password, so request equals verify or init-ace or any of those Unix APIs, even if you specified user equals and password equals on JCL, you can actually type in a pass ticket there. So any place you can accept a password, we will accept a pass ticket. That's the concept of this. Now, the way this works is there are profiles defined that'll identify where the key is, right? And you can control this at the application level. Right? Now, the PTKT data class, that is where the profiles which have this information have the pointer to the key or the key itself. That class must be active. That class must be rack listed. And in the profile that you define is an application name, optionally user and group ID names as well, to allow a more finer granularity of mapping of keys to the environments. Right. So this information, as I said, is in the PTKT data class profiles, and there's a specific segment, the S sign-on, the single sign-on segment. And you'll see keywords such as key masked, which is where you put then the key that you wanted stored in the RACF database, or key encrypted. And key encrypted, you would specify the string that represents the key, and then RACF would take that key, stick it in ICSF, generate a label, put that label in the RACF profile. That was the original support. A little later on, we gave you the ability to take an existing RACF managed PTKT data key, single sign-on key, and convert it from RACF into an ICSF managed key. That's the encrypt key keyword, migrates an existing mask key to an encrypted key. And we also gave the ability to define the key in ICSF and then simply point the profile to that key in ICSF. That was the key label support. Encrypt key and key label came a little bit later. The key masked and key encrypted, that's been around since the 90s. Now, what we're doing with enhanced pass tickets is we are enhancing the underlying algorithm that's being used for the purpose of generating these password substitutes. So that's really the goal. We're not changing a lot of the externals other than how you tell us that you want to use this, but applications which are generating pass tickets, right, and evaluating pass tickets, in most cases won't have to change. It's simply a matter of how the S sign-on, the single sign-on segment is defined that'll control exactly which are being used. So the capabilities are the same, generated by the trusted application to allow users to use these other applications. It's still an 8-character value that we're generating, right? We're not putting this in the passphrase. This is still being placed in the password, still generated from a shared key. And I said that the algorithm is public, and the only really secret thing is that the key value that you're using. And I should have pointed out there that you can generate these off platform. You can code up, and many have coded up the ability to generate a pass ticket, publish the algorithm, you can generate it off platform, and then pass that pass ticket key into RACF on a ZOS system. That works perfectly fine. So what are we changing? We're changing the generation and evaluation algorithms, right? And why? We're updating from DES to use something a little bit more modern, HMAC with SHA-512. We are giving the ability to enhance the character set that's used for a generated pass ticket. A standard pass ticket is one that is kind of like a standard password, uppercase, numbers, things like that. We have the ability to specify, nope, I am supporting mixed case passwords, so I want to generate pass tickets, which are mixed case, and you can do that. And the last of the enhancements is we give you a configurable validity period. A standard pass ticket has a validity period of plus or minus 10 minutes, right? Now we're giving the ability to say that we want plus or minus n seconds up to 600, so up to 10 minutes. But if you want to make it much shorter, you can do that. What kind of applications might be doing that? The original intent of pass tickets were these single sign-on applications, and we recognized that they might be across different systems. You might have clock differences that might have to be accommodated, not time zone types of things, but clock differences where we do things in GMT, but you might have a few seconds, maybe a few minutes difference. So we gave you that 10-minute window to accommodate that, as well as any propagation delay that might occur. But it turns out there are a lot of applications which are generating pass tickets on a particular ZOS image for submission of work on another address space on that same ZOS image. So you don't have that clock issue, and you probably don't have a 10-minute propagation delay from one address space to another. If you did, you got some serious things to take a look into. But in that case, you might want to choose something that's not 10 minutes, might be 1 minute, might be 30 seconds. So we give the ability to configure that validity period. So everything from an administrative viewpoint, there's a lot that's similar. It's still PTKT data class profiles. It's still the S sign-on segment, or the SS sign-on segment, but we've got some new keywords in here, right? We have, let's see, the ability to specify whether you want an uppercase or mixed case password substitute, mixed case password being generated. So that'll be the type. The timeout value, that's where you can specify the number of seconds that this pass ticket is allowed, plus or minus from that time. Replay. Now, in the traditional pass tickets, you would put replay yes or no, whether replay was allowed or not, in the Apple data field in the profile. No, for an enhanced pass ticket, we gave it its own keyword, which is just a nicer interface for that. Question, are these going to be available on ZOS 2.4? I believe the answer is yes. I should have looked that up, but Jim, I'll find out for you. I apologize. But yeah, not everything we do gets rolled back to prior releases. So I'll say right now, for those of you who are looking at the vSAM and encrypted database support, that is not rolling back to an earlier release. But other support such as this does. I just don't remember how far. All right. The callable services that one uses if you're generating these certificates in a ZOS environment are CVT PTGen. That's actually a field in the RCVT in storage. You basically branch to it with a parameter list, or RGenSec or RTicketServe. These don't change whether you're generating a pass ticket or an enhanced pass ticket. It's really the specification of the options on that S sign-on segment. But what we did do is we did enhance for enhanced pass tickets, and in a few other cases, the diagnostics that come back when something doesn't work, the generation doesn't work, or the evaluation fails for one reason or another. You get some additional information, and that is quite useful when something has been misconfigured. As for logging, we do log when pass tickets or these enhanced pass tickets are used, and the information goes into our usual SMF80 records in event 1, 81, or 82. So exciting stuff there. In general, if you have an application that's using pass tickets, it should not have to change when you're using enhanced pass tickets. But there are some cautions if you want to do things like use mixed case. If you're using mixed case, you have to make sure that your application supports mixed case passwords. So in particular, there are some characters that you have to be able to specify the dash and the underscore values in the password field. You must not fold pass ticket value to uppercase, but that would be true for any application which is supporting mixed case passwords. You of course have to have setter ops mixed enabled. Other than that, you shouldn't have to worry too much about application compatibility between legacy pass tickets and enhanced pass tickets. So, nice implementation. If you're looking for additional information, there's the information. Is V2R3 and V2R4. I should have read my presentation, but hey, my excuse is I was on a beach in Hawaii for the last 10 days. It does roll back. There are the APAR numbers right there, and some links to the documentation. So Jim, excellent question. Thank you for asking. All right, moving on to the next topic. I know there are people who like to write things in languages other than assembler. I kind of like assembler. But if you're writing things in, I don't know, Metal C or environments like that, you might like to have some header files that map some of the standard RACF things that one has to worry about. And now you can do that in ZOS V2R5. There are a set of files, they're shown here for things like the SAF parameter list, the mappings of some of the SMF or the RACF SMF records 80, 81, and 83, and some of the other parameter lists and control blocks like the accessor environment element, the fabulous ACEE. So they're out there, they're shipped in /user/include/ZOS. And in that other data set shown there, sys1.cahdr.h, along with lots of other header files. All right, next topic. Alter access for discrete profiles. This is something that has been a requirement for many, many years. So think about it. We have this thing in RACF called administrative authorities. And administrative authority allows you to do something that sets, alters, changes a security environment, a security setting for your environment. So examples of that would be things like having the special attribute or having the auditor attribute. These let you set system-wide RACF security options. If you are the owner of a profile, then you have the ability to administer, that is, make changes to the contents of that profile. You can change the access list as an example, change the universal access. Right? You own the profile, you own the security definition. That gives you the ability to change that security definition. We have a few other ways. We have cloth, right? The class authorization, which allows you to create profiles in a particular class. So if you have cloth for user, hey, that gives you the ability to do some user administration kinds of things. We also have some very specific profiles in the facility class and the Unix priv class and a couple of other places that give you the ability to perform very specific administrative functions, perhaps a password reset as an example, right? And then the last thing we have, field level access checking, or FLAC. This gives you the ability to do things in non-base segments if you have a certain administrative privilege defined in some profiles somewhere. So all of these are ways of giving administrative authority to a user. But then we have this interesting anomaly, and that's the anomaly of if you have a discrete data set profile, right? Or general resource profile. If you have a discrete profile and you have alter authority, then you have not only alter authority to that resource, right? Whatever that might grant you, but you also have the administrative authorities over that profile. So not only do you have the ability to alter whatever that thing is, you have the ability to change the security definitions for that profile. Right, so remember our basic accesses in RACF of none, execute, read, update, control, and alter. Alter is at the top. If you have that highest level for a discrete profile, then you have the ability to change the profile definitions, right? Everything except the owner, actually. Right, you can change the access list, you can change the universal authority, whatever it might be. Right, so that's a pretty extraordinary authority to have. Now, there are a couple of different ways you can get alter authority. You could be in the access list with alter authority, or you could be in a group which has alter access to a profile, or a standard access list with an ID splat entry of alter. It'd be crazy to do that, but yeah, it's technically possible. Or universal access of alter. Again, not likely, but could happen, right? Or you could have alter authority by virtue of a global access table, a GAC table entry, right? Again, not particularly likely, but one could see something like that. All different ways of getting alter authority. If you have that alter authority, what does it let you do? It lets you list the profile, including the access list, lets you copy that access list to another profile. Right? Both of those, I think, are relatively harmless, quite frankly, but the ability to modify or delete the profile, that's pretty significant. Right, so you can alter the base segment, everything other than the owner keyword. You can change the access list. You can delete the profile, and of course, when you delete a profile, now what answer will RACF return when an authorization check is being performed? Well, it'll be the now most specific profile, which could have a completely different set of access authorities. So That's one set of issues, but you can also create conflicts, right? You can create, if you have alter authority to a profile, you can create a discrete global profile, right? That you can create one that has allows a whole different group of folks to have access to something. If you're using member grouping profiles, I'm going to just summarize these last 3 points to say you can create conflicts. If you have the ability to have alter authority to that member profile name, you can create a grouping profile or vice versa. So there's just lots of potential complexity you can introduce by having alter authority to a discrete profile. So now we're giving you the ability, the option to remove that aspect of alter authority on a profile, right? It's a switch. You have to do something to make this happen. And you can do it on a class basis, and you can make exceptions for individual users. What's the value of this? Well, it's narrowing the scope of what somebody can do, right? So, yeah, insider attacks, we're always concerned about those. Yeah, it's a nice way of removing one particular aspect of an insider attack. It's easily provable to auditors in the sense that, oh, just take a look at these profiles in the facility class of this particular name. These tell you what classes we have disabled alter authority processing for. And the other thing, this is kind of one of those things we've just had to deal with. If somebody came to me as a RACF person and said, hey, I'm thinking of putting in this new RACF authorization check, and we're going to require alter authority to this thing, I immediately have to say, well, realize if you are requiring alter authority and you think that your users, your clients are going to be defining discrete profiles, then you need to understand of this quirk. And, can you use something other than alter? Can you use control as an example? Right? Control has a very specific meaning for data set profiles, but for general resource profiles, it's really whatever the resource manager wants it to mean. So there are a lot of times you'll see control used for general resource profiles, and that's the reason why we're trying to avoid the use of alter. Well, we're now giving folks a different way of ameliorating the issue that might occur if you have alter authority to a discrete profile. So here's what the profile is. It's a facility class profile, and the naming for this profile, the resource name, is irr.alter.classname, right? Now, if you don't define this profile, nothing happens. If you do define this profile, then update authority will allow that alter authority, right, for profiles in that class to still have the administrative effect, right? So if you have alter authority and you also alter authority in a discrete profile, and you also have update authority to irr.alter.classname, then alter authority means you can make changes to the profile. But absent of that, if you don't have alter authority to that profile, now, excuse me, I said alter, I meant update authority. If you don't have update authority to that profile, then that alter authority that you have on the profile doesn't give you the administrative privileges that it did in the past. So that's pretty cool. Now, a couple of just little things about this. That covering profile name, right? It has to begin with irr.alter. Right? So if you had a true generic profile, if you will, of splat or splat, asterisk, or asterisk, asterisk, right? That won't match. It has to start with irr.alter. It has to start with that. And we did that explicitly to make sure if you happen to have a facility class profile that was irr.splat for some reason, or just splat or double splat, it would not match. That's the reason why. Now, one of the things this means you can do is if you want to give a particular user the ability to have alter authority, still have that administrative meaning in a particular class, you can do that. And the way you would do that, right? Let's say you define that irr.alter.splat profile with the UAC of none, boom, I've just turned it off for everybody. But let's say I got a guy named Andrew, nice guy, trustworthy gentleman, right? We still want him to have alter authority, mean he has administrative authority over that discrete profile, but only in a particular class. In this case, we call it $my class, could be any class. We would simply define a profile of the name irr.alter.$my class, give it a UAC of none. So right at this point, things are pretty much the same as if we had that other profile right above it defined. But now I can permit to irr.alter.$my class in the class facility the user ID Andrew and give him update authority. And now his alter authority to discrete profiles in the $ my class is preserved. You of course have to do a setter ops rack list refresh after this, something that I often do forget, but you're smarter than me and you probably don't. Now, a bit about logging for this. Yes, you can turn logging on, right? You can say audit all if you want. Only successes will be logged. That's by virtue of the nature of how we wrote the code. And just detail. If you're looking at the SMF records, because of the way RACF does some of its checking. So, for example, there's an example where if you have group special authority, right, that is sufficient in some cases to do one of these administrative things. But because of the nature of the code, the check that we do to see about the discrete profiles is done in a place that we didn't want to alter a lot of that structure. So the logging is still a good indication, but I can't say that it's 100% accurate to understand who is using alter authority now for the purpose of doing administrative things. So I'm going to pause for a moment. I don't see any questions in the chat. So let's move on to the next topic, which is certificate fingerprint support. So I hope everybody realizes these thing called digital certificates, which have been around in ZOS and RACF for a very long time. We're using them for lots of different things: server and client authentication, program signing, setting up encryption packages, all that SSL validation. But sometimes it's nice to have a handle, a way of describing a certificate that is independent of the platform from which it came. So sometimes you can talk about a certificate in terms of its issuer's distinguished name and subject's distinguished name and serial number. Those three things usually uniquely identify, in fact, will uniquely identify a certificate. But there's another way that folks have been using to describe or identify a certificate. So for example, in various places you can go, you can actually see this certificate fingerprint value. So if you were to happen to go into your browser, let's say it's Chrome, and you go into the part of your browser where you can start looking at certificates, you'll get information about the certificates you have defined. And then they almost all have this fingerprint section, which will show you a hexadecimal string that identifies that certificate, right? So what we're doing now with RACF and ZOS 2.5 is we are supporting the creation and display of these digital fingerprints. So you can look at a certificate now as stored in RACF or as being processed by RACF or PKI services, and then compare it to a value that's been generated somewhere else, but using the same algorithm. So now you can determine with a very, 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 wait for it, very high level of confidence that these are in fact the same two certificates. And basically what is, it's a hash of the DIR encoded X.509 certificate, and then that's hashed using some algorithm, and what we're using is SHA-256. So where will you see this? In the RAC dcert list command, you'll see this in the output of database unloads, and you'll see it in certain certificate SMF records that we create. That's for RACF. PKI services has a couple of places, the web page where they list certificates, the utilities they have, and the SMF records that are created by virtue of PKI services actions. So if you would do a RAC dcert list chain, or check cert, that's what it would look like. You don't have to ask for anything. You just start seeing the information that's highlighted in yellow here, the certificate fingerprint. We do tell you the algorithm we use to generate it, and there's the hex string. Similarly, if you're looking at the output of database unload, right? Database unload has a 64-character field which will contain the certificate fingerprint. The SMF records that RACF creates, specifically 66, 67, and 84, those APIs will those SMF records created by virtue of the use of those APIs will have certificate fingerprint information. And here's an example, PKI services, one of their web dialogues. There you show it, the certificate fingerprint. And another example here. Great. Next topic, FIPS support. FIPS is Federal Information Processing Standard. It's a sort of a US thing. The FIPS standards often talk about cryptographic strength. And for, I hope everybody realizes, we support a Kerberos environment supported by RACF, but it is a separate component that actually how we package it together. But in our Kerberos support, we are now support FIPS style encryption or FIPS compatibility when using the NDBM, too many letters, too early in the day for me, database. We now have a FIPS enablement. And it's there's some specifications you do in a configuration file to make that happen. There's a lot more detail in the handouts, but I'll be honest with you, a lot of folks are taking advantage of Kerberos, so I wanted to talk about some of the other stuff. So a question from Lenny, are the fingerprint generated on the fly or stored? And how are existing certificates managed? Excellent question. It is generated on, I believe it's on the fly. Certainly the case for database unload, and I think that's for the others as well. But I will validate that. I will make sure. Thanks, Melanie. All right, now moving on, RACF vSAM database support. So I really like statements of direction in the sense that they allow us in IBM to talk to you about things that are coming down the pike. So, and I got, thank you, Wai Choi, for the confirmation. Wai Choi, the queen of certificates, chimes in that I got it right. Yay. All right. So I love statements of direction because they give you a little peek into what's on the roadmap, what's on the radar display, what things can you expect to see sometime in the near future. So in the preview announcement, we had a statement that said as follows: IBM intends to enhance pervasive encryption through RACF support for the use of an encrypted vSAM dataset as its database in specific configurations. Right, there's a lot of stuff in there, and I wanted to parse that statement a little bit with you. So the first one is IBM intends. So IBM intends says that this is not necessarily all in the release that's coming out, right, that we are announcing, in this case, ZOS v2.r5, but we'll have some support coming out sometime in the future. So support for an encrypted vSAM RACF database is not and will not be in the base release for ZOS v2.r5. Said another way, if you ordered it, because it just became generally available and we're all just itching to go to the latest release of ZOS, right? The encrypted vSAM dataset support is not there now. There are a few more things we have to take advantage of and a whole bunch more testing that we have to do to make this happen. So support may be delivered in a future release or as continuous delivery on ZOS v2.r5. So you're setting your expectations on when you can see it. All right. But there's a lot of stuff in there, right? This encrypted vSAM dataset, well, does that mean you have support for a non-encrypted vSAM dataset? Excellent question. Hold the phone. You'll get the answer to that in just a moment. So right now, prior to ZOS v2.r5, RACF is its own access manager, right? So we have our data set, or maybe you have multiple RACF data sets comprising a RACF database. When RACF wants to go and find some information out of the database, whether it's information about the system options, usually stored in something called the ICB, or the inventory control block, or the actual security definitions for a particular resource stored in profiles, right? RACF has its own mechanism for finding that information. We have our own index structure. We have our own profile formats. We have our own metadata in the form of RACF templates. And fundamentally, RACF takes all of that information and it searches through its store of data using relative byte address technology. This happens to be the same technology used by vSAM, right? RBA. Those RBA values are similar and yet different, right? And the most important thing to realize is that when RACF in the non-vSAM RACF database manager support is doing what it needs to do, it's usually reading the database using EXCP-VR. Right, so RACF is responsible for lots of different things when we are our own access manager. We're responsible for our own buffering, as an example, or store caching of information that we think might be reused. And we have lots of things that we do to support that. But we're our own IO manager. We are responsible for our own serialization. And for anyone who's ever looked in the RACF Systems Programmers Guide, there is a section in there that lists all of the possible NQs that we will do, all the serialization we do, and there's a lot of them there. right? That's because we are our own access manager, and we have to make sure that if you're sharing that RACF data set amongst multiple systems, that information that you are sharing is shared with integrity, So you can look through the chapter and see all the NQs. And so just suffice it to say, there's a lot of serialization going on. When we move to, or as we have moved, because you can actually do VSAM in ZOS V2R5, we have to make sure that we are honoring and doing all the right serialization. So we'll get to a little bit of that in a few moments. But why would we ever think about going to VSAM? As I said, encryption was the first reason, but there are lots of other things that started to really make sense. We started thinking about how to do encryption. First is, there's a rich set of VSAM diagnostics and a lot of people experience with using VSAM. So why go out and invent something else? We could have encrypted the RACF database on our own, but taking advantage of the pervasive encryption provided by the access methods really seemed to be a very, very attractive thing to do. Diagnostic skills. And if there are any new performance enhancers that come along, the access methods will be the folks who take advantage of it first. So by hitching ourselves to VSAM, we get to take advantage of all of that. So that was kind of the philosophy. Now notice all of that is independent of the, and by the way, the access methods already do encryption for the RACF data, for any data set. So we found a way to take care of several issues at the same time. So that's a statement of moving to VSAM. Now, for encryption, as I said, that's not there in ZOS V2R5. There's some additional infrastructure that we have to take care of. And when I say we, it's IBM, it's RACF and VSAM and our friends at ICSF. So, the encryption piece, not there yet. Hold the phone, statement of direction. It is on its way. Now, the last thing is, I always said we'd support a VSAM data set in specific configurations. Now, when we said specific configurations, it's a phrase that I sometimes call sufficiently vague, right? But what we meant by specific configurations has to do with specifically how you're sharing your RACF database and the particular RACF options you might have set on, Sysplex communications being one, RACF data sharing being another. All right. It's also a matter of understanding how you share other critical resources, in particular your ICSF data set and the master keys associated with the various LPARs that are sharing that ICSF data set. So all of those come into play into the phrase sufficient communications. So brass tacks, what are we supporting in ZOS V2R5? Right here, right now, if you've ordered it, you're in the installation process, yes, you can move to a RACF VSAM dataset, providing that your data set is not shared. Now, I realize that's really a limiting thing from a production viewpoint. Got it. But you at some point shared will be supported, has to be. But for 2.5, RACF dataset cannot be shared. It can be on a shared device, but you cannot be IPLing multiple systems using that same RACF dataset. Second thing, it must be a single RACF dataset. So if you have your RACF dataset split into three datasets, right? RACF database into 3 datasets, we call it a split database. You cannot use right now in ZOS V2R5 a VSAM data set as your backup, right? So sorry about that. We understand we do need to get to that point, but we had to scope this down from our viewpoint. Your environment must be an application identity mapping AIM stage 3. Now, for those who may not remember what AIM application identity mapping is, it's been around for probably 15, 16, 18 years. The concept here is, I mentioned RACF is its own access manager. RACF has its own high performance index for finding profiles. Alias index mapping was a way for RACF to use as its key to find entries in the index, something other than the profile class and profile name. That's really the key that's used in the traditional RACF lookup when it goes to the RACF database. But if you wanted to use something else, like, I don't know, a UID or a GID, we'd be using this application, you should be using this application identity mapping support. Prior to that, there were mapping profiles in a specific class. And when you moved into application identity mapping, we took the information of those profiles and we actually created index, a completely distinct index from the traditional RACF index. We created that in the RACF database. And the AIM stage 3 simply refers to the stage from going from those old style mapping profiles into the new alias index mapping structure. And the AIM stages 1 and 2 were kind of transitions to get you to where you really wanted to be, which is AIM stage 3. There are some RACF functions that require AIM stage 3 already. So we think most people should be there. I think it's a health check that even would tell you if you weren't there. You've had 15 or 18 years to get to this point. Well, now if you want to use a VSAM data set to position yourself for using an encrypted RACF data set at some point in the future, then yeah, you got to run the utility IRA 00 to move you through the AIM stage 0, which is the starting point, all the way to AIM stage 3. So you need to be at AIM stage 3. Your data set should be free of errors. So UT200 and database unload run without error. And no unusual return codes, no messages, no abends, right? So please, when you think about going to VSAM, just make sure you've done that validation step. The data set must be non-SMS managed. And oh, by the way, that means it must not be encrypted. But again, at some point, those restrictions will be removed. And you must not be in RACF sys communications or RACF data sharing mode, right? So those are the restrictions, and we do anticipate removing them over time. Now, a couple of things that don't change if you're using a RACF VSAM data set. None of the standardized or traditional programming interfaces. So that means rack, route, Ichinti, the RACF callable services, IRX util, any of the RACF commands. Nope, no changes there, right? So if you've got applications that are reading the RACF database or writing the RACF database using any of these, no change whatsoever. We are not changing the serialization structure that RACF is doing. So for those of you who've ever fired up your favorite monitor for serialization, all those sysz RACF and all those sysz RACN NQs, we're still doing those. We've kind of basically just changed the IO manager. So instead of doing EXCP-VR, we're calling services that call VSAM, right? And instead of referring to EXCP-VR, you refer to data that you want retrieved by a cylinder head and record. Instead of doing that, we're doing it by record number. And oh, by the way, the translation from the relative byte address into the record number, it's pretty straightforward. You just take the RBA, that relative byte address, lop off a bunch of bits, and then subtract 1, and that's your record number. So we were very fortunate in the sense that the original design of RACF, and by the way, RACF just celebrated its 45th birthday, but that original design, which was actually based on a predecessor of VSAM, something called Access Method 1, that actually fit very, very nicely into allowing us to take out that EXCP support and instead replace it with VSAM reads of a particular record number. So no changes to the serialization, no changes to any of the programming interfaces. There is just one caveat. There's always a caveat. There's always a little small print. And the small print here is if you read the RACF database directly, right? That is, if you open the RACF database like it's a BDAM data set or a sequential, but if you're just reading it directly, right, then you may have to do something to support VSAM. So as an example, I have some ICE tool things that I do where I would read the RACF database and format the ICB. It's kind of a fun thing to do. That didn't have to change because the thing I was using, ICE tools, it's understood VSAM versus non-VSAM. But if you are doing some low-level stuff and reading the RACF database manager, you may have to do something to do this. Now, the one question that always comes up is, well, wait a second, I don't know. I have a vendor product, right? Does my vendor product read the database directly? And the answer to that is we let the vendors know that this was coming a long, long time ago, April 2020, and in September 2020, there's a meeting that occurs where we discuss proposed changes to various ZOS components. We presented this to the vendors. We gave them a mechanism where they could test with a VSAM RACF database very, very early on. It turns out that mechanism to test was create the RACF VSAM data set, or a VSAM data set that would be your RACF VSAM data set, and do an IDCAMS repro into it. Hey, That's it. So a lot of the vendors who were interested in that got on board. We had an ICN, an IBM change notification, 1775 went out in August. And as far as I know, the vendors have done their testing and life is good from that viewpoint. So now we'll just talk a little bit about the process of moving to that vSAM data set. There are, in my mind, two ways of doing this: with an IPL or without an IPL. Now, in a single system, that's not necessarily in my mind, a big consideration, because single systems, single non-shared RACF databases tend to be test systems, right? Over which you have a fair amount of control, and my experience has been it's a little bit easier to schedule a Plex-wide IPL for those, because the Plex is only one system and it's usually a development kind of environment. But as we move into this environment where the database is shared among systems, or the database, or you're in the RACF data sharing mode as an example, I suspect most people will be going down that without an IPL path. So let's talk about the with an IPL path. Pretty straightforward, right? You create that vSAM data set, right? That's going to contain your RACF data. It's going to be your RACF data set. You create a new ICHR DSNT, a RACF data set names table, or an IRPRM XS member. So I love our ParmLib support that came out in ZOS V2R3 that points to that vSAM data set. Then you use either UT200 or UT400 to copy your primary RACF database into that data set. You're doing this at a quiesce time, so there are no changes being made from that point until the point where you re-IPL using that new dataset names table or that RACF parameter library member. So that's the with an IPL process. But I think the more interesting one is going to be the without an IPL. And the process is remarkably similar. The way you would do this without an IPL is you create that vSAM data set, right? So you create the data set that is going to contain your RACF data set in your RACF database in vSAM format. You then inactivate your current backup data set, inactivate your current backup data set, and then you copy the primary RACF data set into that new data set using a new parameter on IRUT200 called rename activate. We'll talk about rename activate in a little bit of detail in a moment, but the concept of that is you're going to copy that data set, that primary RACF data set, into that vSAM data set, and then under the covers, UT200 is going to rename that vSAM data set to become your backup data set, and it's going to rename your backup data set into that archive-DSN name that you specify on parm equals rename activate. Right, so that's how you'll do this without an IPL, and then of course you'll have to I should have put this on there. I apologize. RVary activate your backup data set. Now, how do we expect people will do this? How will they minimize their risk? The first thing is, I expect that just like we had to do somewhere back in the 90s with RACF 1.9 when we moved to the restructured RACF database, right? Which, by the way, you had the IPL to get through. So we learned a really big lesson there, right? You don't have to, the IPL is not a requirement here. But just like we did back then with the restructured RACF database, we recommended that you do this process to your backup data set, right? And then you run with a non-vSAM primary, in this case, and a vSAM backup for some period of time to get yourself comfortable and confident that the processing actually works. Then you do the RVary switch to swap your primary and your backup. That makes your backup inactive. Well, do the RVary active for your backup at the same time. So now you're running with a vSAM primary and a non-vSAM RACF backup database. Run with that for some period of time, and then go through the process of migrating that backup data set to a vSAM environment, and then you'll be vSAM. There are some naming conventions that we'll talk about in a moment. Now, let's talk a bit about this rename activate processing. This is on a parameter on IRUT200. I hope folks remember that IRUT200 already supports a parm equals activate, and the concept there is you have an active primary and an inactive backup, and then you want to copy the primary into the backup and then make the backup active, and do that all under RACF serialization, right? And I say RACF serialization, that's not sysdsn serialization. It's RACF serialization that we do specifically to protect the contents of the RACF database, right? So that's what activate does. What rename activate does is it adds a few data set renames in there. And so again, the starting point here is you have your RACF database primary, a RACF dataset primary, and an inactive backup RACF database. And then what you will do is you run with parm equals rename activate, and in the rename activate, you specify a dataset name, and that's the dataset name to which you want your RACF backup dataset renamed as part of this process. So the way this works is, what we'll do is, the way UT200 works, it copies from sysRACF to sysUT1. What the first thing it does is it renames the sysUT1 dataset to the inactive backup dataset name. It copies the sysRACF dataset into that inactive backup and then activates the backup. That's it. Right, so we do this renaming and then some copy operations. Now, I will point out that rename activate works with both vSAM and non-vSAM datasets. So for any of you who've ever heard the phrase R-very dance, which is a way of bringing in a different RACF dataset into an environment, you can use rename activate in that R-very dance process and eliminate the need to do your own renaming during the steps involved with the R-very dance. So I'm going to harp a little bit on UT200 because understanding this is kind of key to the whole process. Understand that with UT200, with rename activate, we're talking about 3 different data sets: the live primary, the inactive backup, and the target of where you want the vSAM data set in this case, where you want the copy to occur. That's sysUT1. And the steps are, again, we rename the current inactive backup data set to that DSN value specified in rename activate. We started calling this the archive data set. I kind of like that name, right? The archive, it's where your backup data set that you had ends up. That's where it renames. Then we rename the sysUT1 data set. That's the target of the copy to the RACF backup data set name. Then we copy the data in, right? And then at the completion of that copy, an R-very active is done under the covers to make that backup data set active. Couple of requirements on the data sets, those 3 data sets. Both the input RACF data set, the sysUT1, which in this case will be the vSAM data set that you're copying to, and the archive data set must be covered by generic data set profiles. You cannot have discrete data set profiles. Why, I hear you cry? We're in the middle of copying data sets, and if during this process we had to, we're in the process of renaming data sets, and if in the middle of this process we're renaming a data set covered by a discrete profile, that discrete profile will get renamed, and it just got messy. So that's the requirement. Generic profiles must cover these 3 data sets. It could be the same profile. That would be kind of unusual, but it has to be a generic profile covering each data set. Otherwise, the utility will do a return code 12 and refuse to do anything. So we check that first. Discrete profiles there, we continue. No discrete profiles, we stop. If during this processing we get an error of some type, let's say the copy fails because there's not enough space in the output data set, right? We will go back and we will rename things back to where they were, right, when we started. Here's an example of the JCL that you would run. So there you see rename activate with rename activate with RACF.back.old. That's what we want the current inactive backup data set to be renamed to. We'll call that the archive data set. We'll see this example in a little bit. Yeah, we have time to go through the example. So here's the example. Starting point. We've got an active primary and active backup. RACF.prim, RACF.back. First thing we do is we create that vSAM data set right down here. Right now, one thing I want to point out is note that I explicitly created that vSAM data set with a component name that's not the default. RACF.back.vsam, the default component name would be RACF.back.vsam.data. I've chosen, and I suggest you do the same, to make the data component name RACF.back.data so it will match the backup name when the rename occurs. When a rename is done, it's an IDCAM's, the IDCAM's processing to do a rename, it renames only the cluster name. That's the guy here. It does not rename the data component. So we want those to match. It's a nice convention. So that's a recommendation there. So at this point, all you've got, you still have your old RACF data sets in use. Nothing has changed here. The next step is you inactivate the backup. Right. So at this point, you've got an inactive backup data set. The next step, running. So now you run UT200 rename activate. The first rename takes RACF.back and sets it to whatever you specified in rename activate, RACF.back.old as here. Then we have the next rename, the second rename, where this data set, right, the sysut1 data set is renamed to your RACF backup data set name, RACF.back. And oh, look, now RACF.back.data, we've matched the vSAM convention of the cluster name appended with .data is the data component name. So that's our second rename. Then we have the copying of data from the active primary into the inactive backup. Next step you do is the setups. Next thing that happens under the covers, rename activate, activates the data set, and life is good. You now have a vSAM RACF active backup data set. So a little later on, when you want to get comfortable, when you got comfortable with this, you'll do you'll want to go out and make your vSAM backup your primary and vice versa. So you'll do an rvary switch and an activate, and that's great. Now you've got a vSAM primary and a non-vSAM backup, right? But I strongly suggest make sure that you update your data set names table, or better, your RACF parm live entry. So now you have a parm live entry, your IPL stuff matches what you have actually in processing. Question from Lenny: if ITCAM's alter performs rename, then I must get yes, I guess the data sets must reside in the same catalog. Yes, 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 yes. Important safety tip. Thank you. All right.
Mark, there was a question from Rob Van Hobergen. He said, are fully qualified generics, are they allowed?
Are fully qualified generics allowed? I think the answer is yes. That's a great question. I will have to validate that. 2 chocolates to Rob next time I see you. All right, I apologize, I missed that one. All right, a couple of other things. We're over time. UT200 uses IDCAM's repro under the covers now instead of IEB Jenner. Right, so that means that the messages that you might have seen that are produced as a part of this copy will now change. So there's an example of Jenner. There's an example of IDCAM's repro. I will tell you, in general, IDCAM's repro gives you a lot more descriptive information than you get from Jenner. So that's a step forward. Last thing, I got this from Marna Wally. Thank you very much, Marna. Some upgrade options, actions to be aware. The RACF TSO helps are no longer available in ZOS V2R5. So that, if you're in TSO and you say help, add user, yeah, those are gone. We really do recommend using the command language reference and having a link to one of the PDF or the whatever we call it now, the book manager way of getting to that data. If that's upsetting to you, RFEs, please let us know. Some clients were a little upset with that, and understandably so. We're making some changes in ZOS V2R4 and later to what RAC DCERT for RSA PKDS keyword. So you just have to make sure that your ECC master key is activated in the coprocessor. And if you've defined the zip or Zoe installation classes, once all of your systems are defined, or all of systems sharing your RACF database are at ZOS V2R5, then you should go out and remove the installation defined version of those classes. All right, that's it for me. I love the fact that GSE supports local charities in lots of different ways. So thank you very much for doing that. There's the link to that. And yeah, you already know, membership. This is a great conference. Thank you again for inviting me. Please do fill out the session evaluations. I do want to be invited back. I love this conference. It's so much fun. So Jamie, thank you for inviting me, and only 2 minutes over. Not bad.
Thank you, Mark, for taking us through that. Gosh, a lot of changes there, isn't there? And as ever, thank you for taking it through so beautifully.
My pleasure.
So Mark has already uploaded his presentation, by the way. So if you go onto the agenda and you see the little presenter man, I always think he's an elephant of some description. But anyway, it's a little presenter with a blue jacket on under the Virgin Money giving messaging. That's where you can download the presentation, or wherever you see that, and all the presentations, that means that there's a presentation available to be downloaded, and you have to be signed in to my GSE to be able to do that. And if it's missing, then just give the presenter a few days just to go and upload it. It will be there, and as the same with the recordings, they will eventually appear on the agenda as well. But yeah, as Mark said, please do give feedback. Remember, feedback equals CPE points for those that need it, because that is used to generate your CPE certificate, and also don't forget you get entered into for the prize draw. So please take the time to do that. So thank you, Mark, once again. Coming up, oh, one final reminder. So I'm glad you joined us, Wai. So Wai Choi is with us. I think I mentioned this morning, that she has a session on Thursday this week, which is basically the next part of her certificate journey. And remember, at the conference last year, Wai gave us the kind of first part of that. So in what she's asked me to remind you all is to, if you didn't attend that last year, then you can listen to the replay. And we've updated the synopsis for Wai's presentation on Thursday with that replay link. So it's well worth listening to that before you join the session on Thursday. So we have a break now until 3:30, when in the security stream, we have our next session with Vanguard. So Brian Marshall is back with us again, and he's going to be talking to us about addressing the top 3 concerns with privileged users. So I hope you can join that. And of course, there's lots of other sessions going on as well. A quick heads up that tonight we have the quiz. And that starts a little bit later. That's starting at 8 o'clock tonight until 10 o'clock, just to allow people to have dinner and deal with children and so on. So hopefully you can join us for that as well. So the day is not yet over, folks. So anyway, I'll let you go and refill coffee, afternoon tea, whatever it is that you fancy, and we'll see you back here at 3:30. Thank you. Thanks, Mark.
My pleasure.